RPA Federationists. Welcome to another episode of White Canes Connect, presented by the National Federation of the Blind of Pennsylvania. My name is David Goldstein. I am the treasurer of the Keystone chapter and the Pennsylvania Association of Blind Merchants. Thanks for joining me on this very special episode during Convention Week here at the NFB of Pennsylvania. As we all head to Harrisburg for the 2023 convention, we thought we would take a look back at one of the best presentations from last year's convention, and that is of the Tactile Astronomy presentation with Dan Gardner, Dr. Matt Marone, and Dr. David Hurd. The next voice you're going to hear is Vice President number 2 of the NFB of Pennsylvania, Emily Gindelsberger, and she is going to introduce us to those three gentlemen. Let's take a listen.
I'd like to welcome everybody to it will be my favorite conference, the final frontier. I've got to do the whole thing, right? These are the voyages of the Starship Enterprise. It was started off as being a 5-year mission, but we're well past those 5 years and then some other sequels. So if you guys have noticed, there's been a huge theme this convention on tactile graphics, tactile interpretation. The parents, our whole thing this morning, and we didn't even get to the clay. We had, as I said in there, I abused Dan Gardner completely this weekend, and he had made some raised line, like tactile coloring pages, and the kids got to enjoy that. And it comes from the heart, and we have a very supportive leadership team at the NFB of Pennsylvania because there's such a need for our students to learn anything tactile, anything that they can get their hands on. And a lot of times it's being denied it to them in the school. They don't have the knowledge, the means, the will to put this in front of the kids and even the adults, because that's why I'm here, because very few of you know, before I lost a lot of my vision back in the pre-ADA days of life, I went to Pitt, and my major was physics and astronomy with a minor in mathematics. I'm a total nerd. This is why I get along with these guys up here. It was like 2 hours on the podcast the other night. And so it has always been something. We just didn't even have computers at that point, which is really, they just started with the thing with Pluto, I think it was. Or it might have been Jupiter. I can't remember. It's so long ago now. And of course, I was the teenager with the bad attitude, so then I didn't want to stick with it. So I still think about going back to this day, but thankfully, the children now and us adults who like to play get the opportunity to really enjoy and explore, and we have the technology. And this brings me to the presenters that we have today. We have, like I mentioned, Dan. Dan is the CEO of ViewPlus. This is why I call you the embosser, dude. ViewPlus Technologies. And that has the Tiger software suite, the beautiful embosser out there that he's been embossing everything for me this weekend. You guys have heard the story. It was a couple years ago, and many emails and back and forth, and then he came to Harrisburg last year, and he just really likes me putting him to work, so he came back this year. Hopefully he'll come back next year to Harrisburg as well. And then, a few years ago, when we were at National Convention down in Orlando, Florida, there was going to be a solar eclipse, and that's when I was introduced to Dr. David Hurd. Well, not personally, but he was there, and he was at the parents' meeting, and he had this wonderful tactile map of the eclipse route and everything. And then he was nice enough to get me multiple copies, and I sent them out to the Bell kids that year. And then he actually ran an astronomy camp this year that was supported through BVS. And Angelina actually got to go up to what was once Edinburgh. It is now PennWest University, and spend a couple days up there in the planetarium with things. And then that brings us to the final person, but the person who's going to be starting the presentation off today. And that is Dr. Matt Marone, who, again, like the other two, felt compelled to pick up the phone when I called for whatever reason. And you get an email out of nowhere like, hey, there's a bunch of blind people in Pennsylvania that really want you to come up and talk. So I can't even remember who it was. Whoever, if you're here, I fully give you credit because somebody put a link up on the listserv that was toward a program that Dr. Marone was doing down in Georgia. And I was like, oh, I got to meet this guy. This is like all me. And so I'm like, Lynn, can I please? And she's like, okay, guys. She's asking me to do stuff again. And so I emailed Dr. Marone, and he got on the meeting with us. And so that's what brings us to this point today. So I think I put everybody asleep, and I will... yeah, I know. The space stuff is coming. I'm just full of hot air. I have no space. But I am going to turn it over. Do you have your own microphone? Because I'll hand this one back. I'm going to turn it over to...
I don't have a microphone, no.
Okay.
Maybe I can share yours.
You can share. I can hand you mine. Okay. And so...
I do have a microphone holder up here that I can put it into. So.
Perfect. That's probably where he stole it from. So.
You probably stole it from there.
No, it was handed to me. It was like that when I got here, okay? I will, the order we are going to go is Dr. Marone is going to present first, then Dan Gardner is going to come up, and then Dr. Hurd will present last. And, these guys have, like, a lot of fun stuff and a lot of information, so I hope everyone enjoys it. Thank you.
Thank you. Made for this size microphone. Oh, yeah, it's just a little tight. Doesn't seem to. I'm a physicist, but both. It just seems the microphone's too heavy for the mic stand.
Yeah, you have to.
Joe's coming to us.
Okay, or we can bend it back a little further, but I might just have to hold it.
Try that.
Oh, we got it. Okay.
Try that. Or I can give you a lapel mic.
I think we got it, Joe.
Okay.
All right. Can you all hear me? I said y'all because, I'm from Macon, Georgia. That's not where I was born, but that is where I live. Thank you. So, all right. Well, so I teach a couple of things. I teach physics and astronomy and also in Asian studies. And last year, a friend of mine from the Macon Museum of Arts and Sciences said, we're going to do some work with the students at the Georgia Academy of the Blind, which is only a few blocks away from Mercer University. And I had been there before doing some things. And she said, well, we're going to work with the Georgia Academy of the Blind, and we want to do something about heliophysics. And I thought, okay, that's going to be interesting. And so how am I going to be involved with this? Because I teach astronomy, and we have a really wonderful planetarium at the Museum of Arts and Sciences. And the idea was, well, can we do a planetarium show for our students at the Georgia Academy of the Blind? How do you do a planetarium show for people who can't see, simply, right? And I thought, well, I've been thinking for a long time, and at some point I'll probably tell you, maybe not today, how I actually got interested in doing this kind of stuff. But I thought, well, I can try 3D printing some constellations. And so that's what I'm going to talk about today. So we actually did do a planetarium show at the museum in Macon, at the Museum of Arts and Sciences. And I'm not sure, but it might be the first time somebody's actually done a full-blown planetarium show for visually impaired people. I really am not sure about that, but I think we may have made history when we did that. And so I'm doing that by making 3D printed models of the constellations. And I'm going to lead you through one of those activities. So has anybody ever heard of the constellation Orion? All right. Does anybody know anything about the story of Orion? Who was Orion, or who is he? How is he represented in the sky? Does anybody know? Oh, that's Sagittarius. He's a hunter. Okay, good. He is a hunter. He's often depicted holding a club raised in the air, and he has a shield, and his shield faces another constellation, which is a fearsome bull that's looking at him that he's about to do battle with. Anybody have any idea what that constellation might be? Taurus. Very good. Very good. So what I have on the table are some plastic squares, and maybe we can have our friends help you find those plastic squares. So grab one of these. There's only 3 per table. I wasn't sure how many I needed. Well, that's a math function. Oh, your mom grabbed it. Okay, so this one is for you, and ask your mom to give it back. Well, there's some at that table where there are young people. All right. So, yes, they are a little sharp. I did not, so let me warn you about that. I didn't get a chance to go over them with some emery cloth before I came to the conference. These were printed out pretty quickly right before the conference. There is Braille on it, and I want you to try to find the Braille, but the Braille is a little sharp. So orient it so that the Braille is downward, okay? And if there's one extra one, I want to grab one. So, what's that? Yeah, so there should be some Braille at the bottom. And there's also the word Orion on there. So if you can find the Braille, that should be at the bottom. Has everybody found the Braille? Okay. Can you read my terrible Braille and see what it spells? So what does it spell? O-R-I-O-N, right? Now it's going to be important that you can find the R. And like I said, they are a little sharp. I really do need to file them down, so I hope that's not a problem. But can everybody find the R? Okay, so I want you just to feel this thing and get familiar with it. Move your fingers around the edge. Can you feel the corners that have holes in them? Can you feel that there's some holes in the corners? Those holes are for mounting this thing. If you want, you can mount it, or you could put a string through it, or you could hang it on the wall. And now go more towards the center of the plate, and you feel that there's some really big bumps. The bumps may be a little sticky, a little tacky. Those tacky bumps, the reason that they're tacky, A, is it helps you to find them, but also B, they're coated with glow-in-the-dark paint. So in actuality, if the lights were off in the room, there would be enough contrast if you shined a bright light on it, like from a cell phone, and then maybe put it in the darkness, or hung this up in the darkness, shined a light on it, hung it up on the darkness. You may be able to see, depending on your level of sight, you may be able to see these things glowing in the sky, okay, as they would in the night sky. So they do have phosphorescent paint on them. So is everybody oriented pretty well? All right, so you can feel there's really big bumps on there, and those big bumps on there are stars. And the way this works is that the bigger the hemispherical bump is, the brighter the star is in the sky. You'll feel that there are some things that are very, very little tiny bumps, even smaller than the Braille, okay? And those are very, very dim stars. And then you also should be able to feel next to some of the stars there are lines, flat lines, some of them going vertically or to the side, all right? those are the connecting lines that we use to actually draw out a constellation. So I'm going to lead you through understanding what this model is interpreting for you and how this is showing you a constellation. But first I want to get everybody oriented so that the Braille word for Orion is down at the bottom. Okay, so hold it that way in your hand. And then we're going to go on a tour, okay, of this constellation. So now find the R in Orion, the Braille R in Orion, and then just move your finger straight up towards the top of the model, and you'll run into a bump, a big bump. Does everybody feel that big bump? Yep, you feel it. Okay, that's actually the star Betelgeuse. And we're going to start talking about them. Betelgeuse. I think she was setting me up when she said that. Okay, so does everybody, well, you know, in this presentation, I'm going to have to say it a lot of times. Does everybody feel Betelgeuse there? Yes. All right, move your finger slightly to the left, and you'll fall off of Betelgeuse, and you'll feel another bump. You feel that other bump? Is that bump smaller than the big bump of Betelgeuse? Betelgeuse is going to be our reference. We're always going to go back to Betelgeuse over the R. So if you ever get lost, go back, find the Braille, find the letter R, then go up from the letter R to the first bump. That's always our reference point, okay? Does everybody understand that? All right, so moving off from Betelgeuse to the left, you feel a small bump. Okay, now why is that bump smaller? Any idea? It's not as bright. It's a dimmer star. So the way this model is made, the bigger the bump is, the brighter the star in the sky, the smaller the bump is, the dimmer the star would be in the sky. And the little one that you just felt when you went off from Betelgeuse, that one has a name too. It's called Mu Orionis. So it's like the Greek alphabet, alpha, beta, gamma, delta. This is the letter mu. And so it's not the brightest star, and it's Orionis, which means it's in Orion. So it's the Mu star in Orion. Alpha being the brightest, beta being the next brightest, and so forth, unless it's, you know, a named star. So this one is called Mu Orionis. Now, I'm going to tell you something about magnitudes of stars. Magnitude is the way astronomers measure the brightness of a star. And we use this crazy numerical scale. All right, so Betelgeuse, it has what astronomers call a magnitude of 0.43. It's just a number. But this number is related to the brightness, but it's not a linear scale. So don't think if the number is twice as big, it's twice as bright. It's crazy. It actually goes as a factor of 2.5 for each magnitude unit. It's a little bit complicated, but that's okay. So Betelgeuse has a magnitude of 0.43. It's a big bump, and it's very bright. So Mu Orionis, that's a small bump, right? So it's less bright. So what do you think? Should its magnitude be greater than 0.4 or less than 0.4? Well, actually, the way astronomers do it, it goes in the opposite way. The smaller the number, and I'm including negative numbers, the smaller the number, the brighter it is. So actually, that small little tiny dot there has a magnitude of about 4. It's like 4.12. Okay, so we call that a magnitude 4 star, and that would be a dim star. Not an extremely dim star. These magnitudes go out to very large numbers sometimes, or they go to negative numbers. But do you see something? Did you learn something about how astronomers show the brightness of a star? So the way we describe the brightness of a star, the smaller the number, the brighter the star. That seems really strange at first. There's historical reasons for it, and that's why we do it. But some things can even have negative numbers, like Jupiter. Jupiter is in the sky right now. Jupiter and Saturn are in the sky, and they're really, really bright. And Jupiter has a negative magnitude. It's like negative 2.9. So it's much, much brighter. And the full moon is like minus 12, and the sun is about minus 27. So, a negative number, the sun, right? It's extremely, extremely bright. Each time you change the magnitude by 1, like say go from 2 to 3 or 3 to 4, you change its brightness by about a factor of 2.5. So that means that Betelgeuse is 29 times brighter than the Mu star that's next to it, okay? That's just how we do brightness. The Hubble Space Telescope, right? The James Webb is now the big thing, but the Hubble Space Telescope can measure and photograph stars that are about 4 billion times less bright, or 1/4 billionth of the smallest dots that are on that model. The smallest dots on that model get down to about what's possible to actually be able to see. And the Hubble Space Telescope can actually photograph things that are billions of times fainter than that. Now, here's a question for you. Do you think a star that is bright is necessarily close to us? I heard a sometimes. You don't think that a star that is brighter is necessarily close to us?
Well, I think one is really bright and it's really far away.
Sometimes they can be bright and they can be really, really far away, so they look dim. Or sometimes the star is just not putting out a lot of energy, and it's close to us, but it's not putting out so much energy, and so it also looks dim. So you can't just look at stars and say, okay, this one's close to us and this one is far away from us. Betelgeuse is a gigantic star. It's a huge star. Is it bigger than our sun? Do you think the sun is big?
Not that big.
Not that big, no. Not in the scheme of things. No, it isn't. So, kind of average? Okay. Betelgeuse is like 600 times larger than the sun. If you put Betelgeuse where our sun is, the edge of it would go out past where Mars is. Okay? You remember the sort of the order of the planets? There's a little acronym for it. In the old days, before Pluto wasn't a planet, it used to be something like, my very educated mother just serves us nasty pickles, which is my, Mercury, very, Venus, educated, Earth, Mother, Mars. Okay, that's Mars. If you put Betelgeuse where the sun is, all those planets would be swallowed up and the edge of Betelgeuse would be out past Mars. And then, your mother just serves you nasty pickles, so you've got Jupiter is the just, Saturn, right, what's the us? Uranus, and then the nasty? Yes, Pluto starts with an N, right, okay. And their orbits can cross, so. Okay, nasty and then pickles, right? Okay. So, Betelgeuse, like I said, is our reference star, and it's pretty far away from us. It's huge, like I said, 600 times greater than the sun, but it's 430 light years away. What's 430 light years mean? What's a light year? Yeah, it's the distance that light travels in a year, right? It's not a time unit. It's not like seconds or minutes or something. It's not a time unit. So it's the distance that light travels in a year. Fortunately, Betelgeuse is gigantic and very far away. Okay? Mu Orionis, the one that seems very dim, it's 150 light years away. So it's really dim, but it's closer to us, right? It's 150 light years. Betelgeuse is so bright, but it's 430 light years away. So you can't just say that, well, if it's really bright in the sky, it must be closest to us, right? That just doesn't work. And Mu Orionis actually isn't just a star. It's actually 2 binary star systems. There's actually 4 stars there. But you can't really see them through a telescope so easily that there are 4 stars. You need really good resolution of your telescope. All right, so that's just a little bit of a fact about that. Now, anybody have any idea what the color might be of some of these stars? Stars have different colors. Yeah. They have different colors. Sometimes stars are red, they're blue, sometimes yellow, sometimes whitish looking. Betelgeuse has a red color. Okay? So Betelgeuse has a red color, and on my model, what letter is it above in the word Orion? The R. Remember, if you get lost, go back and find the R. And Betelgeuse has a red color, and it starts with what letter?
R.
No, B. B for Betelgeuse. Now, there is another star in the constellation Orion named Rigel. It starts with an R. Okay? But actually, its color is, anybody know? Yes, it's blue, right? So the star that starts with R is blue, which starts with a B, and the star that starts with a B is red, which starts with an R, so B tells you R and R tells you B, right? It's really easy. It's very obvious. Perfectly logical. You know, that's what I tell my astronomy students, though. I tell them all kinds of stuff that doesn't make any sense, because if somebody tells you something crazy that doesn't make much sense, you remember it. And that's what I want them to know. All right. Well, we're going to move away from Betelgeuse for a minute. So get your finger back on Betelgeuse. Make sure everybody can find Betelgeuse. Are we all on there? All right. So now what I want you to do is move your finger a little bit to the right, and keep moving to the right until you bump into something. Yes, a set of 3 vertical bumps. Exactly. Very good. Is everybody finding the set of 3 almost vertical bumps? No, that's not where the nebula is. So this is Orion. This is Orion's belt. Okay? Can everybody find Orion's belt now? So you feel those 3 dots? What's that?
The belt is the only possible part of that.
Can everybody feel those 3 dots? Okay, good. So that's what we call the belt of Orion. And, you know, this is like the easiest thing to find for sighted people in the sky. It's at this time of the year, you go outside, 9 o'clock or so in the evening, around this time, maybe 10, depends on your tree line, if it's blocking your view. You go up outside, you'll find those 3 stars very, very quickly. So this is also one of the first constellations I teach my students, because it's easy to find those 3 stars in a row. Okay? So those 3 stars in a row, that is the belt of Orion. And that's where Orion has something else that's connected to that belt, which he needs. What do you think that might be? A buckle, yes, to keep his pants up, right? He has that. And hanging from the belt is also a sword. Okay? Now, we'll talk about the sword and what's down in the sword in a couple of minutes, but he does have a belt. Okay? Has everybody found the 3 stars that are in the belt? And actually, another way to find those 3 stars in the belt, if you get lost, is to go and find the N in the Braille. So you can try that. Go back to the Braille, find the word Orion, and look at the N in the Braille, and then go straight up from the N, and what do you hit?
3 little dots.
The 3 little dots, exactly. So if you get lost at any point, you can always find the N in Orion and Braille, and then go up and you'll find the 3 dots.
Is the top star in those 3 the dimmest one? Is that why it's smaller?
It is slightly dimmer of the 3. That is correct. You felt that. That is a little bit smaller, and it is slightly dimmer. Very good. And that top star has a name. Anybody want to know what the name is? It's called Mintaka. And then the one below that is called Al-Nalam. And then the one below that at the bottom is called Al-Natak. So you got Mintaka, Al-Nalam, Al-Natak. And Mintaka actually is from a word that means belt. Okay? So it has an odd name to us, but it actually means belt. All right. The last star, the one on the bottom, that's Al-Natak. Now, Al-Natak is kind of an amazing star. It puts out more energy than the sun does. You think it puts out, 10 times more energy than the sun? Is that a lot? 10 times more? Not cosmically speaking at all, you're right. 10 times more, 100 times more, 1,000 times. I feel like I'm doing an auction. Let's keep going. It's not even 10,000 times, it's 100,000 times. Imagine in 1 second that star puts out 100,000 times more energy than the sun does. That little one on the bottom there. Isn't that amazing? And if we were close to that star, what would happen? If that was our sun, would we be here today having this conference? Probably not. Fortunately, it's 826 light years away. So it takes its light 800 plus years to get to us. How long does it take the light from the sun to get to us?
8 minutes.
Right. This is 800 years and a little more compared to 8 minutes. So think about an 8-minute duration of time and think about an 800-year duration of time. Okay? That's the difference. So fortunately, it's a lot further away. All right. So everybody following along with me? Yes, sir. I see a question. Radiant energy in the form of heat and light and electromagnetic radiation.
So I have a question.
Yes?
So why are the colors different? Is that because, like...
The temperature.
Oh,
The easy reason for it is simply temperature. So when something is hot and it's just glowing sort of red hot, it's hot to the touch and it would burn you. But as you go up in temperature, it gets more and more bluish or whitish hot. That's really, really hot.
so are all the stars made of the same gas?
They're all mostly made of the same gas. The most common gas in the universe is hydrogen, and next to it is helium. Pretty much everything in the universe is made of hydrogen and helium, and then there's other stuff. But if you yeah, there's some oxygen too. That's right. All right. Are we on those 3 stars in the belt? All right, go down to that bottom star now, which is called what? Did we know the name of it? Do you remember? I know I went through this really fast. Al-Natak. All right, good. So now move your finger to the right of Al-Natak in a horizontal fashion. And do you feel any small bumps to the right of that? You feel one. You might feel one big one and 2 little teeny tiny ones. It's hard to distinguish them, but they're there.
Oh, not on the line.
Not on the line, no. You got them? Okay. That's where the Orion Nebula lives. Okay? Now we're in the sword of Orion, and that's where the Orion Nebula is. The Orion Nebula is very famous. It's a big, huge cloud of glowing gas. And one of the famous things about it is the fact that it's a big glowing gas cloud, but it's also a place of star formation. This is a place where we actually find early forms of stars. Some people call it a star cradle or nursery. It's a place where stars are born. All right? So that's the Orion Nebula is down there. Okay. Now, we're almost done. I don't want to take all of your time, guys. So how am I doing on time? About done. Okay. See that? Well, I'm going to do one more star. Okay. And so go back up to the top star in the belt. Go to the right with your finger. Do you feel another big bump? That big bump is Rigel. Okay? Remember I told you there were these 2 stars that one was red and the other one was blue? And so Rigel's the one that starts with the letter R, so therefore its color must be? Oh, you got it. Exactly. Okay. Very good. So that's the star Rigel. It is also a very huge star. And I'm nearly out of time, so I'm going to scroll down a little bit here, and we're going to go to one more star. Now, this one's going to be a little bit difficult to find, okay? And let's see, go back to the 3 stars in a row. Does everybody find that one? The belt of Orion. Now you're going to find a very light connecting line that goes up diagonally to the left. Has everybody got that? All right, move your finger along that line until you bump into something. Did you bump into it? That's the star Bellatrix. And that star Bellatrix is important. The Bellatrix actually means like a female warrior. And this star is just above it, and to the right, you'll feel another connecting line. So find Bellatrix, go a little bit off to the side, going up and sideways to the right. Do you feel the connecting line? Keep following that, and you're going to slam into a whole bunch of other stars, very, very small ones. Some of them are smaller than the Braille dots on here. Can you feel those? They're sort of a shape like an arc. Okay, that's the shield. That's the shield that Orion is holding as Orion is facing down Taurus. All right? So we just basically went through the constellation Orion a little bit, and all on this 3D printed model. I'm also doing 3D printed models of mathematical functions, which I don't have time to tell you guys about, but later if some of you want to take a look at that. So that's another project that I'm working on with the math teachers at the Georgia Academy of the Blind. How do you know what a parabola looks like? Or a cubic equation? Or lines with different slopes if you're learning about algebra and functions. So we're looking at ways of printing out mathematical equations where the teacher can basically program the function in Excel, and then that data goes to a 3D printer, and from that we print out what the math function looks like. So your math teacher can change it and make it a sharper curve, or make it concave up or concave down, all these kinds of different math things. Anyway, I don't want to steal their time, so that's about it. And I hope you found that interesting, and thank you very much. Alrighty, guys.
Sandwiched between the two doctors here. I only have my bachelor's degree. Dr. Gardner's my dad. But actually, it was funny. I was thinking about what to talk about because you've heard me talk about how our embossers make marriages better last night in helping remodel your house. And we did coloring pages this morning. So talking about early. But I was actually a working engineer. And one of the projects that I worked on was with NASA on programmable logic. And the big thing with programmable logic was, like your computers and things, if you think of when you get up into space, you don't have the protection of our atmosphere. And neutrons are these big things that come and blast things through and really don't do well for electronics. And so a lot of times, for Apollo missions, they had all these things. They were all worried about lots of things with Apollo because they'd never been there before. But then with the space shuttle, which I'll send the pictures around, or the tactile images of the space shuttle in a minute, they were more willing to experiment with things other than critical life systems. Because a neutron hits something, and if you think of, you have two states, on or off, right? Binary logic, everything electronics is based on binary. If it can go with no reason from 0 to 1, which is what happens or from 1 to 0, basically flip state from getting bombarded with a neutron, it can be rather troubling if it's in a mission-critical system. So the way we work around that was building triple redundancy circuits that would vote and decide whether it was in the proper state. And but the more and more you do with logic design and software design of trying to figure out how do you avoid, in software, we tend to get pretty lazy and write things that are sequential, assuming you'll never get to the stuff at the end. Well, if you can jump to anywhere in a state machine, you can get to a state you've never even defined yet. And so that was a big topic of, I guess part of what I'm trying to say is like all the graphics are great, but there's a lot of engineering and science that just needs critical thinking and algorithmic stuff. Because I was never much of drawing anything. I hated schematics. I loved writing source code for hardware design and software. So that's what I do now, too. It's much more software. And mechanical hardware, I guess, of things that punch paper. But anyway. So I guess one of the things from today is graphics are important. And one thing that I'm trying to get out, and I'm very happy that there's much more discussion on the necessity of having access to them, because I don't know how many times we go around everywhere in the world, and everyone's interested, I'll say 9 out of 100 people are interested. 1 out of 100 has actually had them from the beginning of school to the end. And then very rarely, again, you start looking at the number of people that like math. I think, 10%? Something like that? The rest of people run screaming for math. Yeah. Well, because I did the same thing. I was trying to figure out how I would show how to do math concepts. I have an Excel spreadsheet that plots all of the slope line intercepts. You plug in the y, or you plug in the slope, the y-intercept, and it redraws the lines. You do negative slopes, and it plots the equation, and you can just print it, right, on an embosser. I did this. I had do parabolas, so I put in the quadratic equation into Excel's formula and had a list of data, and so you could do parabolas, and where they cross the axis is where your solutions are. I even went over and beyond what the audience wanted at that conference and plotted the slope of the tangent line, which is the first step in calculus, which is the derivative functions, in Excel. And it took me an hour. But I'm not a scientist. I'm just an engineer. So I had an hour to prepare for a conference talk, and that's what I sat down and did in Excel in less than an hour. And plotted. And actually, the longest part was trying to figure out how big do I make the markers? Do I make them solid or whole or whatever, right? Because I'm trying to read through 400 pages of BANA guidelines to try to figure out what makes sense. And so of course I did it wrong, and they told me all about it. So I'm like, well, can I have a simplified, where's the Designing Tactile Graphics for Dummies book? Me being the dummy. But yeah, and that's, I guess, part of it. Is like the part that was interesting when Emily was talking about bringing this together was like, here we have solving the same problem 3 different ways or 3 different media, but really, and that's the kind of the interesting thing. And then the other part that I find is that everyone's recreating the wheel. It's very difficult to share information, and a lot of times, like I'm here today, sometimes that blind kid's the only one in that school district, and that person's never had any training and knows nothing. So you've got somebody that is trying their best to maybe try to figure it out, and then they're not sure where to look, and then they end up Googling something and then finding that my email address and phone number are on our webpage and call me. And so, I don't know where I was going with part of that, but I guess to me, what I'm hoping is to keep seeing, there's lots of different things that are possible, and trying to get enough momentum and figuring out ways to be able to share that information collectively and have people use it, right? I mean, it's great. I don't know how many times I've brought the U.S. map and things like that, and people are like, "Oh, cool! I didn't know that like Montana wasn't on the coast or that Oregon was," and it's like, and then that takes a lot, and then walk away. And it's like, well, did that change life? All right, did that awareness change anything after that aha moment? And half time I don't have any idea, right? Because it's like a spot in time. And so one of the things that I have been trying to do is to follow through on these stories and find out, right? That's where I kind of touched base with Emily again. Like, you reach out saying, hey, you needed some help finding out how to do plot math equations. And then it's, how did that go? But you're on grade level with math now, right, Angelina?
I'm not taking math this year.
Oh, okay.
What they're doing is they're going to redo the graphics. Now, they were actually out training the TBI on the PixPlus thing. And so she is technically, but they're still working on the graphics.
Okay.
We should be taking after 2 weeks.
Because, yeah, I mean, outside of the Texas School for the Blind, where they get tactile graphics from like age 5 on, I haven't seen that many, and I work with Tim Fallberg at Wisconsin School for the Blind too on math concepts, and it's pretty normal where you all of a sudden around 14, 15 years old, there's no more on grade level. And it's hard to tell if they ever were on grade level a lot of the time because, yeah, you didn't know what they were getting. And I guess that's part of what drives me is, our perspective. My dad went blind when he was 48. He had already figured out theoretical physics. He had already done, and he could build something that he could do. But trying to figure out how to teach someone that had never seen anything how to do that is a totally different experience. And then wherever it starts, right, is a totally different experience. And that's been part of the learning curve for us as a company and then as humans is, how can we figure out something that is possible but also useful and then fits a bigger mission of actually making some sort of difference to where, to me, I'm like, we had a couple conversations, and I don't want to go off on that, but on the quality of jobs you can get or that can get offered, and using your mind doesn't require, as long as it helps not to be distracted. So thinking about things, there's no reason why you should be precluded from that. And a lot of science, like I said, has nothing to do with visual. But yet a lot of the concepts, because they're confusing, get explained that way. And a lot of the materials that are created, it takes someone that understands the actual concept to be able to refactor that information. And so many things are presented visually that are even terrible visually. And we were just having this conversation last week in San Antonio that was above the pay grade of the transcriber to tell them that the data was terribly presented and that they weren't allowed to change the graphic. They had to essentially come up with 400 pages of rules of how to best handle a terrible situation, as opposed to just redo the data. Or sometimes, again, when is a graphic not the right representation for doing that? And that's because that was just today. There's another listserv on POSB about the schematic diagram or the periodic table, and I'm like, it's been a long time since chemistry, and I don't remember which parts are that important. But back to space. It was a really cool. I think it was cool as a engineer to work on space projects because it was one of the ones that, I guess there are some space trucks that go up and go boom, but not on purpose. But a lot of engineering stuff, there's a lot of military aerospace that isn't about science exploration, but more about other worse things. So space is one of the cool areas that was really fun to be part of. And this working on, I think it was Voyager 7 and the new space shuttle that didn't ever get funded, were really fun projects and were very mind-opening from a standpoint of, like I said, being able to switch, thinking about problems that we don't have on Earth with things changing state by themselves. And again, this simple space shuttle diagram has been something that I've heard over and over again as well. That is something that people may have heard a lot about it or heard maybe it described, but just knowing where the solid boost rocket, where the different rockets are that it's attached to, we've heard other, kind of like people going, oh wow, I didn't realize that from the description. I had no idea that this is what it really looked like. And so that's why I kind of chose this one as one example. I have a bunch of showing how comets and showing the phases of the moon and all sorts of examples that are on our website that I've printed out. But I thought that this one was a good one as an example for you to look at. And if you have any questions, now's a good time.
Heather? So is there any intent to get together a database of free 2D and 3D printable things so that a TPI who knows absolutely nothing about a particular type of science can go, okay, we need this type of diagram. And they go in the database and then they go to their nearest 2D or if they're lucky 3D printer and print these things out. So they're not reinventing the wheel every single time that a diagram is needed.
There's a couple different databases.
Hold on, let's use the microphone so that people on the street can hear.
You want to repeat the question, or?
I'll run this mic around for other questions.
So sorry, I was passing out the thing. I didn't get all of the. I heard part of the question, which was the.
So the question was, is there a database of 3D printed models, 2.5D printed models, other materials that TVIs can get their hands on where they're all in one place and easily accessible? Is that correct?
Right.
On the question. And I can say that I know you might want to reach out to, I believe it's Tiffany Held. She's at Ohio State University, and I think she's kind of trying to do just that. I think it's just getting started, so stay in touch.
Well, and there's some, let me say, like my go-to resource for a lot of it is the APH Tactile Image Library. So the Tactile Graphics Image Library is a free resource. It's got a lot of these pieces in it. It's got 3D models. It's got 2D models. It's got, the challenge we continue to see is like you get a tactographic of the United States map. Well, but which part is important, right? It's like all of these things are complex concepts you're trying to get across, and there's never one size fits all, and you have to be able to edit them and things like that. So it's like having a database that isn't necessarily searchable or editable ends up being the biggest problem. Is how do I conceptually come up with these things that are appropriate to the right grade levels and that have all the information and don't change things? And that's kind of why part of the reason why we can't say it's not all the TVI's fault. There's a lot of things that are difficult to figure out how to.
And can I add to that I think a real benefit of a conference like this is you've heard from Dan and Matt, and you'll hear from myself in a minute. And so reach out to one of us. We can put you in touch with somebody that might help you out in a certain venue, okay? Because we all work in a different area, but we can get you in touch with somebody. That's about the best thing we could do.
Yeah. Well, I said, and even when again, I'm not a graphic designer. So that's the other challenge. It's like someone sends me. I just finally paid for a copy of CorelDRAW because there's this whole group of people that do everything in CorelDRAW, and there's tactile image library macros and other things like that I'd heard rumors about but never been able to actually find where they were on which listserv. But that's why I went to the National Braille Association conference and finally got that information too. So there's a whole bunch of different ways to skin the cat as well. I mean, a lot of stuff, if it's done with thermoform or collage, as still is pretty common, those are more like arts and crafts projects. So there's no way to even share those electronically in a lot of cases. And then sharing 3D models and sharing some of even swell paper stuff. Some of that is challenging to share as well because reproducing those, and then the embossed stuff is also making sure that we've been doing a lot recently to try to make it much, much easier to share, at least across our printers or our embossers. But nobody else's embossers will do what we do. And so when we work with places and they want to be able to do, say, tactile walking maps at the San Francisco Lighthouse, they spent 3 years trying to make it agnostic to the embosser and finally gave up after I told them it wasn't going to work because the other guys don't care about doing graphics. So it was just understanding the technologies and the limits of the technology, or being willing to put engineering resources into things. Yeah. So long answer, I guess, but there's multiple different efforts, and there's some that are international. There's some international efforts, and there was actually a pretty good resource list that someone sent me from NBA about different sharing sites. But still, often it seems like it's within this little niche groups of whether it's the Pearson textbook group or the ETS testing group, or it's a little of a. Let's I could go. No, that's back. Okay, it's back. So there's more work that needs to be done, and more ways to provide different options. Other questions?
Okay, let me bring the mic to you. So, and it's bell.
Hi, Dan. My question, and maybe you gentlemen already answered this, and I apologize since I came in late. Is there a tactile graphics conference that folks that are interested in, but maybe aren't like academic, could be going to? I mean, being that I did go to the School for the Blind in Texas a long time ago, before there were as many tactile graphics as there are now. I mean, as an adult, I'm just fascinated by some of these things because, now that I have no vision, I want to be able to feel these things. I mean, like, I haven't been able to see. And then you bring along all of these graphics of, Bugs Bunny and now this fantastic tile. And I'm like, you mean I can see the stars again? So is there a conference like this that we should be going to and advocating at for more of this type of material?
I mean, it's sort of sprinkled around. So there'll be some, I think there's some good stuff that I've seen at, the National Braille Association conference. There was a whole track this last year, but it was, again, more based on sighted people creating graphics for blind people than it was on what we're trying to do, which is, teach you to fish. No, I think the whole industry, right? There's whole prison programs and all this stuff to create Braille that are great economic options. But no, I don't know of anything. The closest thing was I went to there's been two conferences that I've been to one time each. The Midwestern Braille Conference that they did a special focus on tactographics, and then the Tactile Reading Conference in Sweden. Those are the only two that I've had that have tracks on them. Sometimes the California transcribers will have a couple tracks. But yeah, no, man, it's been only in the last 2 years, since we haven't had conferences, that I've started hearing tactographics have been more than a nice to have, and are becoming a necessity. But that's really been a shift in the last 2 years. And CSUN, yeah, I mean, again, if you're talking academics, I say I'm not an academic, so at CSUN I don't get to talk because I don't have a PhD. I just build stuff. So, and if I do, no one comes. So, let's say I did tactograph. I did a talk on elementary, importance of keeping curiosity alive with elementary learners, and showing all these shapes and coloring book type things 3 years ago at CSUN, right before the pandemic shut us down, and 3 people came. So, so I mean, again, trade shows are also a thing. So we've actually had a lot more luck with doing webinars. And again, it's a little bit more challenging to think ahead of time to be able to send the materials out, snail mail, free matter, to get them there. And we've been trying to find out if libraries or somebody else would even have our, it's like, that's where I found Chansey, right? It was like, I finally found a library that had an embosser that I could send stuff to, they could print out for their group, right? So, but that's one I found. And people was trying to find anything in Texas that would print the Touching the News, right? San Francisco Lighthouse was doing it. They lost the grant, but they were doing every 3 weeks. They were doing a Touching the News, something hot. You got to vote on what you wanted to see. So lots of cool Mars helicopters. A lot of I should have grabbed those ones too. Anyway, there was a bunch of cool stuff between sports courts and, where the Ukrainian border, where is it right now, that they were doing every couple weeks, right from the news. But then they lost the funding, right? Creating content in this matter, tactile content gets created by grant money. And when there's no grant money available or nobody to do it, then there's no content. And that was ViewPlus. I mean, I think I talked about it yesterday or earlier today. I mean, ViewPlus was trying to do curriculum and content as a business model, and it didn't work. So, yeah, I mean, so I guess, sorry, a Debbie Downer, but I mean, that's part of what I think we're trying to make it easy enough. That's my talk for tomorrow, is if homeschool moms can figure out how to use our stuff, then why the hell can't the teachers? Yeah. So, So that's kind of, or yeah, we need more training. Like, okay, I got a link on our website. Link it. Oh, I don't have time. You need more training, but you don't have time for training.
Yeah.
So,
Priorities.
all right. Next.
Check 1, 2. Check 1, 2. Can you hear me on this okay?
Yeah.
Okay, because this is a lapel mic. I'm going to be wandering around a lot. So, okay. Wow. Thank you, Dr. Marone. Thank you, Dan. Great stuff. We're all about science. My name is Dr. Hurd. I come from, I teach at PennWest Edinburgh University. It used to be Edinburgh University of Pennsylvania, but who's counting anyway? But so I teach there. I teach astronomy, and I also run the planetarium. But my colleague, Cass Runyon, Dr. Cass Runyon from College of Charleston, and myself, we do accessible science. Now, I was telling Dr. Marone and Dan that, hey, I can take the whole hour and a half if you want, but they wouldn't let me have it. So yeah, come on now. What's this all about, right? But yeah, that's why I wanted to go last. We'll get out of here at 6 o'clock. No, I'm teasing. I'm going to, so I've got like a half an hour, okay? And all I want to do is introduce you to some of the accessible science that we do at PennWest and College of Charleston. So, on your tape, my lovely assistant, my wife, just had to step out of the room with an important phone call. So thank you. Yes. So if you could take these 4 cans over to that table right there. All right. So on your table, 4 bottles of Coke. Okay? So listen to me. Coca-Cola. Yeah. Oh, sorry. Coca-Cola. Okay. So on your table are 4 bottles of Coca-Cola. Now listen, we don't have a lot of time for this. So one of those comes from Earth. Say it with me, Earth. One of those comes from the moon. Say it with me. One of those came from Jupiter. Say it with me. Say it. Mars. So it's your job in about 30 seconds to figure out which one came from which object in our solar system. Go. No, you're not allowed to open them. Okay, 10, 9, 8, 7. Everybody had a chance to experience them? 6, 5, logarithmic, 4, 3, 2, 1. Blast off. There we go. Okay. Here we go. Share out. I want somebody raise your hand. A table, raise your hand to share. I've got this table right up here, front and center. Angelina, go. Share out with us.
Okay.
Say it real loud. Yep. Check 1, 2. There we go. Check.
All right, so which ones are we doing?
Well, we have, what do we have? We have the Earth, we have Moon, we have Mars, and we have Jupiter. Not necessarily in that order. Go.
Okay. So, this first one?
What, the first one? I can't see it. What do you mean, the first one? Describe it.
Okay, the one that's like a normal-sized Coke bottle, that's the one from...
Wait a minute. They all feel the same size to me.
Yeah, but like the weight, that's like... yeah.
What's inside it?
That has liquid in it.
Oh, okay. Which one?
Okay.
One is?
That's the one that is from the Earth.
Earth, okay. Well...
All right. The one that's very heavy, that has the beads in it.
The heaviest one?
Yes. That one is the one from Mars, I believe.
Mars, okay. Good. Keep going. Got two more.
The very lightweight one is the one from the moon.
Moon. And the fourth one.
And the fourth one, that's like the sort of heavy one. That's the one that's from Jupiter.
All right. Nice try. Not all of those were right, but thanks for playing today.
Oh, no.
Okay. Yeah, that's great, though. That's good. So somebody else share. Here we go. Right over here. This table. Here, I've got a mic for you. Here, man.
All right. So I don't know what I'm supposed to represent, but I'm going with the very heavy one that's all solids but almost feels liquid and super heavy. I'm going with that is Jupiter.
Okay. The most massive one, the heaviest one is Jupiter, according to this table.
And I don't know why, but Mars, the liquid one.
Mars, liquid.
And then Earth is the shaky one that's slightly heavier.
Earth,
than,
shaky.
Yep. And then Moon, the shaky one that's got the least matter.
Lightest one is the moon. Great. Thanks for playing. Not quite. Okay. Let's hear another table. This back here. Let's grab the mic. All right. Here we go.
There you go.
Check 1, 2. Here we go. Okay. There you go, ma'am.
Hello.
Hello. How are you? Good.
All right.
Felt like I was on Jeopardy. I'm sorry. Say it again.
The very lightest one.
Yeah.
That one is the moon.
That is correct. Next one. Next heaviest one.
This is Mars.
That is correct.
And this, the liquid one.
Heaviest one is Jupiter. That is correct. So the bottom line, boys and girls, is this. So you go and you put a $1.25 in the machine on the moon, and out pops that one. Feel it. Shake it. Feel it. The lightest one. Out pops that, and you say, wait a minute, I just got ripped off. Right? And yet, to Jupiter, and you put a $1.25 in the machine, and out pops the heaviest one. Feel it. Feel the heavy one. And on Jupiter, you deal. Yeah? So, but really, wait a minute. Are you getting a better deal on Jupiter and a rotten deal on the moon? That's right. Thank you. You did great. Yes, you do. You win a free book. We'll get to that in a minute. Okay. So that's very good. So anyway, these are some of the accessible science activities that Dr. Cass Runyon and myself try to do, and we're all into what's called universal design. So in other words, if we're making it accessible to this particular population, chances are it's going to be even more accessible to another population, right? And so we do lots of different activities. But like I said, I'm very limited in time today, so I'm going to move right along here and get to our next demo here. And my lovely assistant, Dan, I mean, my lovely assistant, my wife here, is going to, here, would you pass one of these out to everybody? Actually, you can take some and give to Dan, too. So I want everybody to grab one of these beads, okay? I want everybody to grab one of these beads. And can you, just one. Everybody gets, they're tiny. They're tiny. Uh-oh.
Hang on.
Here, go, just don't worry about it. We'll collect them in a minute. Dan, can you grab some of those and pass them out? Okay, so everybody grab one of those beads real quick, okay? And we'll get the rest later. Just kind of pass them out. Now, what you're all getting is, Dr. Marone, help me out, about 6,000 degrees, I think. You're getting the sun, right, on the photosphere. 100 Kelvin, yeah. Okay, at the surface, so about 6,000 degrees Fahrenheit or so. You're holding the sun there. Don't let it burn you. Ouch, man. Oh, you just dropped your sun? Yeah. What's your name, ma'am? Heather, say it again.
I said, don't worry, Marcia. I spilled all the damn suns. Okay.
Can we edit out that one word? So this is children's program here. so anyway, you're holding the sun right now, and it burns, doesn't it? But I want to come back to Dr. Marone's talk here with this. Is everybody ready? What constellation did he highlight? Orion. What was one of the brighter stars in Orion? Betelgeuse. Betelgeuse is a red supergiant star. So have you ever seen the movie Honey, I Shrunk the Kids? Well, we're going to play Honey, I Shrunk the Sun. And I just shrunk the sun down to the size of that bead. Does everybody have it? It's the size of a BB. It's 5/32 inches. How do I know? Because I took calipers and measured it. Okay, so it's really, really tiny, right? So we've shrunk the sun, our star, called the sun, down to the size of that bead. Does everybody have it in their hand? Yep. Okay, don't let it burn you. So if we shrunk our star, called the sun, down to the size of that BB, or bead that you're holding, how big would that star called Betelgeuse that Dr. Marone talked about be? Is it bigger or smaller? It's bigger, right? He said it's a lot bigger. So how much bigger? Okay, 600 times. And what would that be? Okay, well, I'm kind of a nerd like these others too, and I did the math. It would be exactly 9 feet in diameter. 9 feet in diameter. Now, to get a perspective of that, I want you to touch and feel the table that's in front of you. And if you can, without knocking the beads over, Marsha. Or who? Heather. Who am I throwing under the bus? I'm sorry. Well, if you can reach across your table that you're sitting at there, or just kind of get an idea, guess what the diameter of your table is that you're sitting at? It's not 9 feet. It's not 8 feet. You're getting warmer. It's 5. It is. How do I know? Because I got a tape measure with me, and I measured one. All right. So your table sitting in front of you is 5 feet in diameter. So Betelgeuse would be 9 feet in diameter, much larger than the table you're sitting at. So, see, we scientists like to use models. Why? Because things in space are either way too big or way too small to grasp in your mind. So we like to use models. So are you holding that bead there? Yeah? That's the sun. Compare that to the size of your table. The table is more on the order of a star called Deneb. Deneb in the constellation of Cygnus that we'll get to in a little bit. Okay, but Deneb is an interesting star too. But Deneb would be about that big. Actually, a little smaller. It'd only be about 3 feet in diameter. But who cares? You know, we're getting this perspective of how really big these objects are. And Deneb, 3 feet in diameter. Betelgeuse, 9 feet in diameter. Do you know what the largest known star is? The largest known star is called UY Scuti. Yeah. I think he's my neighbor where I was growing up. Yeah, UY Scuti is the largest known star, and guess what? Okay, you're holding the sun. Don't let it burn you. The sun's pretty big. It's like, 1.5 million kilometers in diameter or something like that. That's pretty big. So on that scale, the sun's the size of that bead. How big is UY Scuti? Betelgeuse is 9 feet in diameter.
Bigger than this room.
Okay, that's a good guess. That's a little bit on the large scale. It'd be 22 feet in diameter. 22 feet. So generally what I'd do is I'd have string, 4 tables together. Or I'd have string or tape measures, and so the students would come up and feel, okay, here's the edge of UY Scuti. Let's walk to the other edge, holding your sun, okay? So we use a lot of scale models to accessibilize science. We like scale models. Dr. Runyon and myself, Dr. Runyon at College of Charleston and myself, we also have developed many tactile astronomy material for astronomy. And on your tables are some books. I would like you to find the lunar book. It is called Getting a Feel for Lunar Craters. Getting a Feel for Lunar Craters. And it's down below there somewhere. It's this pile right here. There you go, bud. And there you go, Angelina. Yeah, you should have it. There you go.
I got it at the.
Okay. Now, does everybody have Getting a Feel for Lunar Craters book in your hand? Everybody. Now, the first thing I want to say is you will not turn that into me. I don't want to see it again. You're taking it home and using it. And if you need more copies, if you're like, wait, I got 4 students, see me, I will get you extra copies. Everybody takes one of those home. Now, let's stay on the cover for a minute. Heather. Is this Heather or Marsha?
I'm Heather.
Heather's getting way ahead of the game now. She's like on page 3. Okay, on the cover, you'll notice in the lower right-hand corner is a QR code, and I think it says in Braille, scan here or something like that.
Scan for text.
Oh, scan for text. So, guess what? If you scan that QR code, the text pops up. Now, I can't guarantee this. We used to have it in accessible Braille. We have an audio file there that you can listen to the text. So there's no text in this book. Where's the text? Scan the QR code. Okay? So that's where you find the text. So I want to walk you through just a couple of these books quickly because I know my time is limited here. But let's just start with this book here. And I'd like everybody to turn to Tactile 1. Turn to page 1, Tactile 1. And notice that up in the upper left, forgive me, at the top is the title. What's it say? What's the title? Tactile 1, the full moon. Okay, and up in the upper right-hand corner is the scale. What's the scale for that particular tactile?
174.
1 centimeter equals 174 kilometers. Now notice that up in the upper right-hand corner, you'll find a centimeter bar that will give you a feel for how big a centimeter is. Now you can place a finger in there and say, well, I think this finger of mine happens to be about 1 centimeter in width. Are you with me? So figure out which one of your fingers happens to be about 1 centimeter in width. That's going to be important down the road. You're pink. Okay, great. It varies for different people. So I'm just reading, if you were to scan the QR code for the text, I'm just reading from the text here. I'll do this rather quickly. Let's start our exploration by observing the overall appearance of the full moon. Study the lunar surface featured on Tactile 1. Note that the tactile number and title is centered at the top of each tactile. The scale of each tactile is found in the upper right-hand corner and represents how many kilometers each centimeter on the tactile represents. A centimeter bar found just below the scale will help remind you how big a centimeter is. It may be helpful for you to use your fingers and determine which of your fingers is closest to being a centimeter across so that you can use that finger on each tactile as a guide. But remember, each tactile has a different scale, so your finger will represent a different amount of kilometers for each tactile. So guess what, guess what, ladies and gentlemen? While we're sharing with kids, they are accidentally learning math, right? So anyway, we'll get to that in a minute. On Tactile 1, move your hands around the outer perimeter of the moon and you will feel a ridge line meant only to define the shape or outline of the moon. The real moon is actually a sphere, or like a ball. Here it is represented as a circle, and the half you are exploring with your hands would come up out of the page towards you. So when you scan the QR code on our books, up comes what we've tried, not perfect, but we've tried to give you a very rich description of them, okay? We hand these books to so many people and they say, these are really cool, and they explore them, but they never go into the text to really richly understand what they're really trying to get across. Okay, let me skip to Tactile 2. I'm just going to skip around here quite a bit. Tactile 1. Just for sake of time, normally, like I said, we could spend an hour exploring lunar craters. Tactile 2, what's the title? I'm sorry, say it again? Tycho. Turn to Tactile 2 in the book. Be sure and touch the centimeter bar in the upper right-hand corner of the tactile and note the number above it to get an idea of scale. What is it? I'm sorry? 8 kilometers. So each of your fingers is 8 kilometers. Tactile 2 shows 2 views of the crater Tycho. The tactile towards the top of the page represents a top view or bird's eye view from high above the crater. This tactile shows how the crater would appear if you were soaring high above the crater looking down on it. So that's what's called a God's eye view or a bird's eye view. So you'll notice that tactile, the top tactile, you'll see the outer rim of the crater, the top tactile. Does everybody see that rim? You got it, Angeline. I want to see everybody touching it. Good, good. This outer rim here. Okay, everybody got that outer ridge? Good. There it is. Now, I got a question for you. I'm going to come back here. You guys got the outer ridge there? Okay. Does this one have a bump in the middle of it? Yes. Okay, I'm simplifying. I'm going off script here. This is scary. But there are basically, this is not rocket science here. There are basically 2 types of craters. Ready for this? Complex and simple. There we go. If a crater has a central bump or a central uplift, it is called a complex crater. If a crater doesn't, it's called a simple crater. Turn to Tactile 3. Turn to Tactile 3. What's the name of it? Okay, good guess. Moltke. Moltke. Tactile 3, Moltke. Explore the tactile, the top tactile. Does it have a central uplift region? No. Guess what Moltke is? Simple. Now, the bottom tactiles on all these are what we call cross-sectional views. Cross-sectional views. So it's as though, like if you peel back the layers of an onion, you see the different layers. That's what the bottom tactile is on each one of these. And you'll notice that with Moltke, indeed, there's no central uplift region, right? Turn back to Tactile 2, please. Turn back to Tactile 2. Now, explore the cross-sectional view. Start from the left. Start from the left side. You'll work up to the crater rim. You go down into the crater floor. Do you see that? It moves up on the... Yeah. Oh, yes. I'll get to that in just a minute. You'll see the central uplift region. It goes back down into the crater and then back up to the other crater rim. Is everybody on the same page with me? Yes. All right. Great, because I don't know what page I'm on. All right. So anyway, the top tactiles are always the bird's eye view. The bottom tactile is the cross-sectional view. And there's a very rich text that goes along with all these that you can explore on your own. But that's the difference between a simple and a complex. And is it Marcia or Heather?
Heather.
Okay, so Heather had pointed out, she noticed that on Tactile 2, it's a little more shallow. Now, remember, the scale's different, but you did make a good point because you'll notice that it's more shallow than like the crater for Tactile 3. Notice how, and that's called the depth-width ratio, all right? And what we find is that with these simple craters, they tend to be much deeper with respect to their width. Whereas complex craters, even though they're massive and big, because of that central rebound, they tend not to be so shallow, or they tend to be more shallow compared to their width. But anyway, and then we don't have time to explore it, but I have a whole tactile book on Mars and the Curiosity rover, where we went to Mount Sharp, and I want to look at one more thing here. Let's see. Yeah, Tactile 2. Yeah. Park there on Tactile 2 for a minute. Look at the cross-sectional view. Is everybody on the cross-sectional view? Bottom, Tactile 2. Bottom, Tactile 2. What can you tell me about the central uplift region and the crater rims? What can you tell me about the central uplift region compared to the crater rims? Almost the same height, but not quite. How are they different?
The central uplifted part
Get there. Go ahead. Say it again.
The central uplifted part is higher than the bottom, lower than the top edges by maybe it comes up 2/3 from the bottom compared to the edges.
Okay, did everybody agree? Did everybody hear that? And do you agree with that? That the point here being that as I get over here close to the speaker, I get problems. Or is that Marcia? So I got to stay away from Marcia over here. Things really strange start happening when I approach Marcia. Joe. Anyway, here's the point. Boy, I lost my train of thought there on that one. But that's a good point. See, physics does not allow, listen to me, physics does not allow that central uplift region to be higher than the crater rims. Ever, never, period, end of discussion. So we go to Mars, to Gale Crater, and guess what? The central uplift region is higher than the surrounding rims. What's going on there? Well, you'll have to join us for a program sometime, because I'm not going to tell you right now, because I don't have time.
I joined his
Actually,
camp last year, I can tell you.
hey, keep it to yourself, Angelina. Okay, listen, I don't have time to go. Okay, put that one aside, but take it home. If you want more, everybody can take a copy. In fact, all these copies in here are yours to keep. Turn to the one that's called Earth. Find the one called Earth. Does everybody have a copy of Earth? What's the title of it anyway? I don't even know.
It says Earth Tactile View of the Blue Marble.
Say it again.
It says Earth Tactile View of the Blue Marble.
Okay, that's always good that I know we did our Braille right, or at least half right. Anyway, so this is a new release. This just came out in, January of a year ago or so. Or no, December of last year. This one explores a little bit about satellite imagery of the place we call home, Earth. All right? And again, we don't have time to explore it in detail, but guess what? Scan the QR code, and what do you get? The text, okay, which is better than me rambling along here. So let's turn to Tactile 3. Everybody turn to Tactile 3. Well, one's cool, too. Okay, Tactile 3. What's Tactile 3? How are we doing over here at this table? The Heather table? Or wait, is this Marcia?
I'm still on page 2.
I'm sorry, we're on page 3. Okay, what is Tactile 3? What's the title? Landsat 9. Landsat 9 was launched about almost a year ago. A little over a year ago. Launched in March. Oh, man. Back up. Landsat 9 was launched in October of last year. Okay? And there's a tactile of that. What do you suppose that honeycomb feeling thing that jets out to the right is? What do you think that honeycomb thing that kind of...
A solar panel?
Yeah, bingo. Is it labeled?
It's labeled.
Oh, nuts. Wow. Shame on me for labeling things, right? Okay, anyway, that's the solar panel, so that's how Landsat 9 is powered, solar panel, obviously. But anyway, that's taking images of the Earth. Real quick, turn to 4. I'm not sure where I'm going. Yeah, 4. What's 4 a tactile of? Antarctica. And if you notice there, first of all, there should be an X in the middle, about in the middle. Do you feel a little X? Yeah, it would be very difficult tactilely. And I apologize for that. But the X, there should be a crisscross or an X in the middle. And that's the center, that's the what? What would that be? The South Pole. But also notice that there's some dots. And the key for those dots are in the lower left-hand corner. What are those dots? Yeah, penguin colonies. There are 5 main penguin colonies. And guess what? If you scan the QR code to get the text, yes, you'll find a video and audio files of the different penguin populations. And if I was thinking and brought it up, I'd bring that up and you could play it maybe at Dan's. Yeah, well, hey, I just put her wherever, baby. Anyway, so I probably should have. Oh, key's supposed to be at the top. Okay, I just learned something. That's why I come here. So, but those penguin colonies, you can actually hear a audio file of those different penguin colonies. They're all right there. Please, now, one more real quick. What just happened in 2 months ago now in Florida? 2 months ago, what ravaged Hurricane Ian? Turned to Tactile 6. And you'll see, I think, one of our most beautiful tactiles we've ever developed. There is a tactile. That is what a hurricane looks like. What do you think that center? Yeah, can you see the eye there? Okay. Yep. No. So see the center. Okay, the center eye and the physics and the dynamics of a hurricane, of course, you can explore if you scan the QR code for the text. Yes, bingo. Okay, great. Okay, put that away. Make sure you take it with you. All right, real quick, I'm running out of time. I'm going to take less than 10 minutes here. There should be a book on your table also. It should be a tactile guide to the solar system. So grab that one. There's only a few of them, I think. PennWest University. Where were you? Why weren't you at Edinburgh University?
A long time ago. It would have been Edinburgh. You weren't there.
Okay. Anyway, that one again. This one is just again. Dr. Marone alluded to it. Dan mentioned about different ways of communicating things for different purposes. And it's tough to get things to scale by size and to scale by distance. So what this is up in the upper right-hand corner or in the right page is to scale by size, kinda. To scale by size, kinda. Okay, we did the best we could. And then along the bottom, starting clear over in the left-hand corner, everybody go way over in the left-hand corner, way over here. Way over there. Left-hand corner, go. And on the bottom, that's where they're to scale by distance. What can you tell me about the inner solar system? What can you tell me about Mercury, Earth, Mars, according to the bottom tactile that starts from left? Yes, here, back here. Hold on. Okay. What's your name?
My name's Harriet.
Harriet, go.
Harriet, go. That is my name. Harriet, go. All right. The inner planets, they're very, very close together, whereas the outer planets, they're very spread out, and the distance is greater between each of the outer planets.
Beautifully done. That's absolutely right. And if I had time with you, what we would do is Dr. Runyon and myself, we've actually developed an audible scale model of our solar system, which is a lot of fun to do. We have a lot of fun with that because you become living planets, and we understand the inner solar system, the outer solar system, by using our audible scale model of the solar system. Okay, enough of that. Here I'm just going to mention I just want to mention it here. In 2017, the United States of America was blessed with a total solar eclipse. Well, in 2023, in October of 2023, the continental United States will be blessed with a solar eclipse. Only it'll be what's called an annular eclipse. And in 2017, I've got some up front. If you want to come up and explore them, you can. In 2017, no, who was that? Heather? Marcia and Heather. I want to see both of you after class briefly. Okay, so anyway, in 2017, we developed a tactile book called Getting a Feel for Eclipses, And Emily alluded to that, and Angelina was able to use that in her class and was kind of able to instruct her classmates on what was happening in the night sky. So for 2023 and even better, 2024, at which time Pennsylvania Western University, thank you, will be in the path of totality in April of 2024. So I've got some prototypes. I've got a prototype of a map of the United States showing the path of totality of 2017, the path of totality in 2023, and the path of totality in 2024. And we've been funded to do another eclipse book for that. So by this time next year, we'll have plenty of those books to get out. And just one other thing here to mention, we also just got funding to do something we're very proud of this product, a tactile book that I have some prototypes here also that you cannot have, but you can explore them, on light pollution. How does light affect how we see the constellations? We're very proud of that product also. Okay, Dr. Marone, Dan, myself, all three of us want to thank you so much for attending today. We thank you so much for your attention. And again, please keep the Earth books, keep the lunar books. If you need more copies, we have them. You can keep those solar system tactile books also. But I don't know if I have enough for everybody, but maybe I do. Thank you. Emily?
Thank you. Oh, contact information, someone asked?
Yeah, you can talk to me afterwards, or I actually have some. Well, I don't have those fancy Braille business cards like I see. QR code. Yeah, scan the QR code. My name and contact should be on there.
Awesome. Well, thank you guys very much. We really appreciate all that you're doing for science and for blind students and adults too. So thank you very much for showing us how space is the final frontier.
I hope you enjoyed that look back at the 2022 NFB of Pennsylvania State Convention presentation from Dr. Marone, Dr. Hurd, and Dan Gardner. It was outstanding to be in the audience for that presentation. I hope you're excited for this year's convention in Harrisburg. Please reach out. Let us know what you liked, what you didn't like about this year's convention. Email whitecanesconnect@gmail.com. That's whitecanesconnect@gmail.com. Or better yet, give us a call, 267-338-4495. You've got up to 3 minutes to leave a voicemail, and we will play it on an upcoming episode. Tell us what you loved about the convention, what you hated about it, what could be done better, what you'd like to see in an upcoming convention. Again, 267-338-4495. Please do tell us who you are and where you're calling from when you do leave a voicemail. Thanks so much for listening to this episode of White Canes Connect. Take care.